Hello, and welcome to our first notes video for Computer Science 2 at-home learning edition. Today I want to cover the topic of ArrayList and just do a brief introduction to ArrayList for this week. So let's start off with what an ArrayList is. Well, ArrayLists are just like arrays in a lot of ways. If we recall arrays from Array Unit about a month ago, the purpose of arrays, and then also ArrayLists, is to hold a collection of many objects that are related to each other and of the same type. So for example here, I have in SchoolTool or some other place, a collection of a bunch of different test scores, all of my test scores for the entire year. So without an array or an array list, we would have to do it this way. We'd start with test 1 equals 98, test 2 equals 87, test 3 equals 100, etc. until we got to say test 20, and we have a separate variable, integer or double variable, to keep track of each test score, 20 different variables. And then when we wanted to do anything, for instance, find the average, we would need to reference all of these 20 variables individually, say test 1 plus test 2 plus test 3 plus, etc., divided by 20 to find the average. Well, that's really annoying and it's not very efficient, and so we have a better way to do it. And the better way to do it is things like arrays and array lists. So instead of having 20 variables, we can have one variable. We'll say an array list called tests. And this test holds all 20 variables in a specific spot. This is the one at index 0. This is the test at index 1, index 2, etc. until we get to the last indexed test. And we can access them all using this test thing. We can loop through them using a for loop. And it makes everything much easier that they're all stored in one place with one variable instead of in 20 places with 20 variables. Other examples of situations we might use array lists. We can have array lists of objects. For instance, if we create a student object, we can put student objects in an array list. For instance, maybe again in something like SchoolTool or Schoology, we need a student array list. A bank might want an array list of bank accounts so they can access all the bank accounts in one place. In our mini tennis thing, it might have been useful to have an array list of paddles and an array list of balls. For instance, if you want to have 5 or 6 balls, you don't want ball 1, ball 2, ball 3, ball 4. You probably want an array list of 5 or 6 different ball objects. And these applications of arrays and array lists are countless. So far, I haven't really distinguished between an array list and an array. They're just both things that can hold a collection of objects, but it turns out they have one really important difference that has a lot of implications. If we recall, arrays had a fixed size. When we made an array, we'll call this tests, I suppose. When you made an array, in this set of brackets, we had to specify a size. So we're saying there's going to be 10 tests. And we couldn't do anything to change that size. If you have 10 things in the array and you want to add an 11th thing, too bad, you need to make a new array with 11 spots and move everything from your original array over to the new array. It's very tedious. So this caused some problems in situations where we didn't know how many elements we were going to have. Array lists, on the other hand, can be whatever size you want and will constantly change sizes depending on how many elements are in them when you're adding and removing things. So array lists start off empty. We always start off with an empty array list. I'm going to represent this array list with curly brackets. And then say we want to add our first test score. We got a 98, and then an 87, and then 100. At this point, the array list will expand to include these test scores. So now there's 3 things in my array list, 3 spots. Let's say I go back and do test stretches on the 87 and get it up to a 94. That's fine. And then I can add a new test, 105, 78, etc. It will continually increase in size as I add new tests to it with no limit. It can be as big as you'd like. This also has some implications on some other operations I can provide. So for instance, with array lists, I can insert things in between 2 elements. If I want to add into this 3rd spot here at index 3, a new test, an 80, that's totally fine. In addition, I can delete things. If this 94, I want to delete this 94, I can delete it. And not only will that be removed from the array list, but everything after it in the array list will be shifted 1 spot to the left to fit so that it's all sort of a smooth array list with no blank spots in it. None of this was possible with arrays. It's array list only technology. We can insert things in between, we can add to the end, we can remove elements, and these are all things that couldn't happen with arrays. While all this is happening, as I've said, the size of the array list is constantly changing and just reflects the number of elements that are currently in the list as we've added and removed. So this is a huge advantage. It makes array lists much easier to use for a variety of applications. It does come with a slight performance penalty. Array lists are a little bit slower in Java than arrays are, but often it's worth it for us to make our code much easier to write and understand. So let's get into the actual code itself and what this array list code will look like when we're working in BlueJ or Java. So the first thing to note is that array lists, unlike arrays, are not built directly into Java and need to be imported before you can use them. We've seen import statements recently with AWT and Swing, where we need to include import statements at the top of our code in order to use certain features, and it's just the same here with ArrayList. Anytime you want to use ArrayList at the top of your code, you're going to need import java.util.ArrayList before ArrayLists are usable. If you don't use this, you'll get an error. It'll say doesn't recognize class ArrayList, and you'll remember that you need to add the import statement. So ArrayLists behave just like any other variable, in particular quite a lot like arrays, that we have to declare them. We declare the type of thing in them, give it a name. So for example, if I wanted to create an array list of string objects called names, that's representing the names of all the students in our class, well, my type is an array list, and then right after this I need to include the type of thing that's held in the array list, in this case strings, and I include that in angle brackets. So our type is an array list of strings. I give my array list a name, let's call it students, and then I say it's a new array list of strings. And then since I'm calling upon the array list constructor, I'm going to include parentheses. So this says my variable is type array list of strings, it's called students, and it's a new array list of strings. Note here that we didn't put anything in it. Whenever we construct an array list, it always starts off empty. And then if we want to add things to it, we can do that. Let's look at another example. What if we want an array list of bank accounts? Well, it's an array list of accounts, account objects, like the custom account class that we made earlier in the year. I'm going to call it bank accounts. This is the name of the array list. It can be whatever I want. And then it's going to be a new array list of account objects. Open close parentheses and a semicolon. So this again will create an empty array list, but the things that can go in this array list are bank account objects. One more example that has a little bit of a wrinkle. Let's say I want to create an array list of test grades, like we've seen before. I'm going to say array list. This time the type is going to be integer with a capital I, and we'll get to Y in a second, of ages is a new array, sorry, not ages, of tests is a new array list of integers that's empty. So why did I use integer here with a capital I instead of int? Well, it turns out that array lists, because of the way they're constructed, can only hold objects. They can't hold primitive data types. And so whenever we construct something with integers, doubles, booleans, anything like that, we have to use what's called a wrapper class. And all you need to know is that we need this capital I integer. We would also need capital D double or capital B boolean anytime. We cannot write something like array list of int. This will throw an error and it's not allowed. Other than that, it behaves pretty much exactly as you expect. You just need to remember for integers and doubles, we need this capital wrapper class version. All right, let's talk about some methods that we can use for array lists and what they're useful for. For this example, I'm going to use this array list of strings, students, that holds currently to start with the names Bailey, Finley, Aiden, Dylan, and Reese, and we'll talk about how it changes as we call these methods. So this is the starting point, but it's going to change along every point. So first I want to use the add method. So this method, our array list is called students, and then we call students.add. and in parentheses we put something we want to add to the array list. So I want to add Noah. Students.add Noah. What's this going to do? Well, the add method by default puts things at the end of the list. So this is going to go to the end of the list, and it's going to add Noah. We also have a separate add method that lets you add things in the middle. So let's say I call students.add, I ran out of names, Adam, comma, 3. This 3 tells us where in the array list it wants to be. We want to add it. So it'll go to index 3 and it'll make Adam index 3. Everything after that it will shift to the right. So currently this is index 0, index 1, index 2, and then Dylan at index 3. We want Adam to be at index 3. And then everything after Adam is going to be shifted to the right to make room for that. So now Dylan is index 4, Reese 5, and Noah 6. And Adam got inserted in the middle at index 3. These are the two ways you'll always add things to array lists. Either add to the end by default or add at a specific spot and move everything to the right. I want to take a brief and go back to one that I skipped. We have a size method, students.size. This is a lot like the .length method for arrays. You need to remember that for array list it's size, and this will return the number of elements currently in the array list. So right now it'd be 1, 2, 3, 4, 5, 6, 7. Students.size would be 7. Note that all of these have parentheses because they are all methods. Okay, what if we want to access something in an array list? Well, the default way to find out what's in a certain spot in an array list is the get method. So if I say students.get 5, this will return to me the student at the string at spot 5. So 0, 1, 2, 3, 4, 5. This would return Reese right now, the string value Reese. And we could say, for instance, system.out.println students.get 5, and that would print out Reese. Or we could say maybe something a little more complicated. If students.get 5 is equal to Reese, then maybe we would do something. And this would be true because students.get 5 in this case is Reese. But either way, students.get 5 will return to us the string at that index. If we want to change a value in an array, not add a new one, but change one that's currently there, well, I can do students.set students.set. I put an index, and I put then the thing I want to change that to. So at index 0, I want to change it to Parker. This is going to take the thing at the spot at index 0, and it's going to change it to the value it provided. So it's not going to add a new one like add did. It's just going to change this to Parker, and Bailey will be deleted. I want to make a quick correction up here that I just noticed. These are in the wrong order. So if I wanted to insert Adam at spot 3, I would need to do 3, comma Adam rather than Adam, comma 3. I apologize for that. So again, back to set. Set will change the value. So if I want to change this one, I would say set 6, comma, and then whatever I wanted to change it to. Our last method is remove. Remove is for taking things out. Unsurprisingly, if I want to remove the thing at spot 2, well, it'll find the element at spot 2, 0, 1, 2, which is Aiden. It will delete Aiden entirely, and then everything after it in the array list will be shifted to the right. So now Adam is the new thing at index 2, Dylan the new thing at index 3, because Aiden was removed. Remember that throughout all of these, the size is constantly updating. So remember, we checked size and it was 7. Now the size would be 6, because there are 6 things left in the array list after the removal of Aiden. Sorry, Aiden. All right, getting to our last topic. I know this video is getting a little bit long, but just like for loops were essential for doing anything useful with arrays, it's the exact same thing for array lists. To go through all the data at once, we need to use a loop, and we have a really standard form of a loop, just like we did with array lists. So this standard form is going to look very similar. We're going to start at the 0th element. This time, instead of .length, we need to use .size, but it'll be something like students.size, and then we're going to do I++. And then if we want to access the thing currently in the array list at spot I, we would do, for instance, maybe system.out.println students.getI. So what would this do? Well, this would go through each spot, starting with Parker, then Finley, then Adam, Dylan, etc., and it would print out the thing at that spot in your array list. We'd print out students.getI. This is our standard for loop that works. It looks much like the array one, so it should be relatively familiar to us, but this is something that you need to know. So let's write one problem example together to talk about exactly how this works. So here's the problem. I'd like to write a segment of code which adds up all the elements in an array list of integers, nums. So we already have an array list of integers, nums. I'll just write it here so we remember. We'll say it's already been created, someone's already added all the things to it, but we want to write some code that adds up all the elements. Well, to add up all the elements, I need to keep track of the sum in a variable. So I'm going to say int sum, and it's going to start off at 0. We haven't added anything else. And then if I want to access all of the elements in this array list, I need to use a for loop. So we're going to say for int I equals 0, I is less than nums.size, I plus plus, our standard for loop that goes through all of the spots in this array list. Oops. And then in here, I need to add each value to our sum. So I'm going to say sum plus equals nums.getI. That's going to one at a time take the things in nums. So let's say, for instance, that nums is 1, 2, 5, 0, 10. First, it's going to add 1 to sum. Then it's going to add 2 to sum, then 5, then 0, then 10, one at a time, and add the thing in the array list. And by the end, sum will be the value of all of these things added together. And then, for instance, we could system.out.println sum. We could do something else fancier with sum, whatever we wanted, but this adds up the values in this array list. All right, that's it for me for these notes for today. I'd like to remind you that there'll be a programming assignment. It's attached to the email and also uploaded to Schoology in the remote learning folder. I will also send this out in the email that I sent you reminding you of this video. We have office hours. Our office hours are scheduled Tuesday at 1 p.m. So you've already missed that one for this week probably, but if you're not there. But also Friday at 11 a.m. I'll write those down just so you see them. Tuesday at 1, Friday at 11. Office hours are a great opportunity if you have questions about the programming assignment that I've signed, about mini tennis, or just questions in general, perhaps about this video, or if you want to hang out and play Mario 64. All of this, I'd like you to have this video watched. I mean, you already have watched it, so great. By Friday, and this programming assignment is due on Friday as well. You can turn those in either by emailing me your code, uploading it to Schoology, or by showing it to me during office hours. Thanks for watching, and I'll see you guys soon, hopefully.